All right, if we could start to gather again. Shall we gather at the river? Okay, I'll stop singing now. I see a new guy. There's a new guy. Who are you, sir? With who? No, but I got that one. With what? Jesus. It's Jesus. We just talked about you, Rabbi.
So we are from a company called Carmouze Limestone, a big lime and limestone producer here in North America.
We have not heard about Carmouze Limestone today at all, have we, gents? Thank you. Welcome. Were you stuck in traffic or whatever? Eric? Yeah. All right, we're gonna switch gears a little bit, and I'm going to adjust my talk. I was supposed to do this morning, and then Jordan said, "No, you're not. You're going to do it after lunch." But then we didn't do it right after lunch, so you guys got to get the sugar out of your system, and now I get you at what is called the doldrum of the day. So here's the deal: if you fall asleep, I throw something at you. It's that simple. I'm going to hit you. I did a friend of mine asked me to go speak at a Rotary thing one time, right? So we go there, and it's a luncheon. There's about 120 people in the room. There's one old guy sitting in the back. I made that joke about if you go to sleep, I'll throw something. So I'm going along, and I notice this guy, he's not asleep. His head's back, and he's Zen. I mean, and it's like the people at the table next to him, come on, guys. But he's just out. And finally, it was just irritating me so much. He was probably back where the gentleman in the blue shirt is. I got off the podium, and I got a dinner roll. It was a little hard. And I just tossed it. Well, the dinner roll hit the table, hit his water glass, and knocked the glass of water into his lap. And he went like that, jumped up, and didn't know anything was going on. Well, people somewhat laughed, but somewhat didn't. And I found out later, he was an 80-year-old guy that has narcolepsy. Is that what happens when you fall asleep like that? But he's 80 years old, and he comes to every one of those things because he was like the leader of the Rotary for 25 years. And I threw a roll at the dude. That's my claim to fame. By the way, I was never invited back. Okay. We're going to talk about changing the culture. Here's what I want you to do. I'm going to use, electrical systems as the model. But this is true of any change of culture, specifically within maintenance and reliability. I could have done this on medium voltage, I could have done it on mechanics, could have done it on anything, because we're at some very unique times when you talk about changing the culture. Let me talk first of all, and be very specific, because this is my background. The ABB guys will know it, John will know it from Arizona. But there are 4 major high voltage assets. John's going to say there's more because there's generators. I'm talking about for industrial applications, primarily 4. They are transformers, breakers with an S, relays and protective equipment, and cabling. Now I got to tell you, it looks different if you are a chemical factory or a limestone company or if you're a data center. But they're the same. In the transformer world, you'll find that there's going to be a whole lot of dry type transformers and maybe 1 or 2 oil-filled transformers. If you're in the refining business, you've got 200 oil-filled transformers and a few dry types. So you have different kinds of transformers. Breakers, from oil-filled breakers, you know what the original breaker was? It was a horse. And that's what Edison killed. He wanted to show the breaker system, and he killed a horse. We don't allow that stuff in the world anymore, but that's what he did. And then we went to oil-filled breakers, these big, huge oil-filled breakers that leak, and they're nasty, and they've been around for years. We test them at our company. Then they went to SF6 breakers, gas-filled breakers. And guess what? The industry now is changing from SF6 gas, where we've all agreed there is a new inert gas that we're going to start using. I'm sure that the ABB folks are way ahead of that game and understand those breakers. But breakers are changing. But there's something common to transformers and breakers we'll talk about. Relays and protective equipment, oh my gosh, that's the biggest change in the industry. Why? Microprocessing. You can do things today, and they are doing things. Relays are becoming significantly more capable of doing what reclosers are better than they used to be. So the whole relay and protective equipment is also backup equipment. UPS systems. Batteries, unfortunately, have not kept up, but they will, and there's now a great move, because if we ever fix the battery problem, man, we're going to fix the solar problem and the wind problem and the storage problem, because the problem with those distributed energy resources is the battery storage. You can make it, but what if you don't want it when you make it? What if you're making power with wind and I don't need it? Or what if you're not making power and I need it? And it's changing the whole grid. And then lastly, cabling. There's an article, it's called, I think it was in Energy Central, but it's the $1 trillion cable problem. We don't even realize what we've got as a problem, but most cables, the average cable laying in industrial America is over 40 years old. They were built to last 20, but they're buried. We had one of our customers, had nothing to do with us, but they had a problem and with transformers, and they needed to pull the transformers out and put in new transformers, but somebody had bought the land next to them, built a building, right? The corner of the building went over their cabling for their high voltage supply. They had to go to the company that they sold and said, by the way, can we tear down a corner of your building, get to the cabling, or underground do something? And what do you think that guy said? Sure, that'll be $1 billion. I mean, nobody's going to let you shut that corner of their plant and then cut through it to do cabling. So they decided to cable around it. They were going to do something around it. As they were doing that, they found out the reason they had problems with their transformers is they had 7 splices in cables that wasn't on their one-line diagram. Somebody came along, put a splice in. Where's the danger in cables? Connections, wherever they connect, especially splices. And so cabling has its own set of problems. There was a new coating that was supposed to prevent water trees. Guess what? It's kind of like that PVC pipe that was out a long time ago. It was going to make everything cheaper, better, and then everybody had to replace their PVC pipe, including me. They were putting it in feeds, water feeds from the main into and they didn't last. They started to spring leaks, all kinds of problems. It's a similar kind of a thing with cabling. So every one of those major assets, with the exception of transformers, is undergoing great change. Well, that's not true, because transformers are going through great change. We'll talk about it. So we asked a bunch of reliability VPs. These were people that were responsible for reliability, not electrical system, not just maintenance, but the vice president of global reliability of Cargill was one of them. The head of reliability for Westrock and Domtar and some refineries, primarily all industrial, not utility, but all industrial. We asked them, hey, do you have an high voltage electrical system reliability program? Yep, 8.3% said we're well on our way. 16, nope, 25, we know we should do it. And 50%, no, we don't have a program. Electrical system reliability is the redheaded stepchild in industrial America. Now, I'm 67 years old, and before I die, people will lose their jobs, plants get shut down, stuff happens far worse than a rabbi not showing up to bless the cookies. And it's already happening, a $50 million problem at Alcoa. Alcoa split into 2 companies. I can say that publicly because it's public now. They split into 2 companies because they had this huge problem with their core stock line that went out, and they weren't making any money on that. They could barely keep up with what was being shipped in. But their high line, the line that made for aircraft and made for automotive, it was doing real well. So they split the company into 2. The primary reason was a $50 million loss at a plant that they had because of a transformer failure. The reason I know that is that we got an alert on that transformer. The worst thing you can get on a transformer is gassing. You get a DG, a dissolved gas analysis, right? And when it hits a certain level, we actually have an engineer that has to call within 4 hours to say, hey, you got a problem with that transformer. What's it powering? You need to think about it. It's too late by then, but at least we're doing that. We had one engineer used to call and he'd say, hey, are you sitting anywhere near that transformer, Sean? And Sean would say, no, I'm not. And he said, good, because nobody should be near the transformer. They very seldom catastrophically fail, but boy, is it a beautiful sight, because you can't put it out with a fire department. You have to let it burn out. This transformer catastrophically failed. Fortunately, no one was hurt. And it failed a line that made bar stock aluminum for the rest of their facilities. And that line froze, almost a mile long. That was it. To replace the line was much greater than $50 million, so they just didn't make it anymore. They put that production somewhere else. The overall cost of fixing that problem was $50 million. There are $10 million, $7 million, $1.7 million losses. I'm going to talk about a few of them that were saved, but it's a big deal. The losses from the loss of an electrical system are usually big deals, and we don't think that much about them. We're working on our motors. We're working on all these things. We do vibration analysis up the wazoo. We do IR on our downline things, on our medium voltage and our low voltage. But we certainly don't do a lot with high voltage. Why? It's because it's been so doggone reliable for over the years. You know the mean time between failure of a transformer? You mentioned it, Dinesh, up here, that one of the measurements was mean time between failure. How about 52 years? Nobody's thinking about them. If you've got any other asset that has a mean time between failure above 50 years, no, and that's the power asset. That's what power transfers I'm talking about. But they always come to an end, and that's where we are now. Here's the dilemma. This is what a CMMS, this is right out of, I think, Maximo's, here's what they do. But see, the CMMS is supposed to determine which machines require maintenance. Does anybody's CMMS in here spit out a work order for electrical system maintenance? No. SAP doesn't do it. Maximo doesn't do it because they put it in. It's in there, but nobody does it. I know your asset management system does it. That's the one. You didn't raise your hand, but I knew you had one that does it. So ABB's got Asset Manager, and it'll manage all of these things. I think Doble's got their arms. People have got different systems for electrical systems, but our normal CMMSs don't. You can't determine which machines require maintenance. So guess what we do? We don't. We don't do maintenance on them. Calculating the cost of breakdown and repair. Do we do that on an electrical system? Has anybody done that? You think that Alcoa thought about doing a $50 million, hey, if it was that, somebody would have done something. And by the way, we called the engineer. We called him twice. We emailed him 3 times, and we texted him once, and he never did call back or take a call. I was called down because when it failed, right, we're the testing company, we should have done something. So the vice president of reliability and the vice president of operations were going down to be read the riot act by these people at Alcoa. And as we went down there, I decided to take the head engineer that made the phone calls and did the emails and have him hook up to the system and show his Salesforce record. We called that guy and that guy. We emailed that guy. You didn't respond to it. Well, you sent us so many emails, we stopped, you know. Oh, so you stopped the operational emails? You could stop the marketing emails, but you stopped all emails? How about the phone call? Well, we didn't think. And here are these 2 guys, one especially, trying to read us the riot act for this thing happening. And it didn't happen. Here's the sad part. 30 days later, the guy's name was Ryan, the head of global transformer reliability for Alcoa. And I get a call from Ryan that says, hey, Alan, he was being very nice. He wasn't. He was real ass when he first called us down there. Now he's being very nice. He said, do you mind if I send you my resume? It's career defining. People that avoid it have to find something else because they avoided it. Calculating the cost and better control and organize your maintenance management. It doesn't happen with electrical systems. We kind of leave it as a redheaded stepchild. Now, I can promise you, John works for a nuclear site. There isn't a better example of that being done right at a nuclear site. But that's because the Nuclear Energy Regulatory Commission is told what they've got to do that gives them authority over nuclear sites, and because we're all darned afraid of something happening that we're all going to get green and fall down or get cancer. So consequently, the highest safety standards, the highest reliability standards, the best of the best in our industry, and I'm talking about industrial America, is an example of a nuclear site. And that's why we don't have failures there. But you can't solve it with a CMS. So what are the variables? You got a high voltage electrical system that right now not a lot of people pay attention to. You got a generational shift. If you look in here, Rob, how old are you? 30. I'm 67. There's a huge gap between the 2 of us. My son says that I say I am analog moving to digital. My kids are digital, 30 and 35 years old. You're digital. You can tell the digital people. And you think and act digitally. For most of us, we're analog. I may actually be Amish, right? Well, what does that machine do? I look over there at Mike's machine. I go, oh, Mike, it's a machine. That's evil. Go away. No, but The reality is we have this generational shift, and we keep talking about passing on that knowledge from the older generation to the new generation. What if it's crap knowledge? Don't pass off bad knowledge. If you can do it a better way, guys, come up with a better way. We actually don't have the best way to do it. It might be crap. It might be tutoade. That's the way we have always done it. You know, we had a philosophy at one company I worked for. It was, you can do it yourself or you can do it right. Think about that. Then you have culture change. Everybody hates culture change. We're going through a huge culture change in our society. We're going through culture change at work because of this generational shift, because everything is changing, and because you get these new C-level people that want to make it more profitable, happier people, want the stakeholders happy. What's a stakeholder? Shareholder, customers, suppliers, employees. Employees always end up last, sadly. But they want all of these people happy, so they come in and let's do culture change. Then you hire consultants to come in and do culture change. Some of them bring in software and they make us all angry and they try to change culture with software. But that's all there. But here's what all of that takes. You got to get the organizational support. It was said earlier, if you do not get, and I don't mean, it doesn't have to be C-level alone, but you better get organizational support. Here's the sad part about it. If you're out there on a limb and you get one guy to say yes, and he's that one guy, and then he turns around, it's called the program du jour, the program of the day. Oh, yeah. Don't listen to what he says. Yeah, he's only the CEO, but don't listen to what he's saying, because it'll pass. He'll be gone in 3 weeks, 3 months, 3 years. Just keep doing what you're doing. Everything we do fights against change. There used to be a primate center in Atlanta called the Yerkes Primate Center. There was also one in Italy. Those centers, they did research with animals. The Yerkes one has been shut down because it was inhumane. Do what? Still there. Yerkes is still there.
My daughter went there last year.
Okay, so my wife went to Emory, but the primate center did something. In the U.S., I think they used, I believe it was orangutans, and in Italy they used chimpanzee, but they put them into their defined and refined area. They put 4 animals. Italy used 5. They put 4 in there. And then through that, it was a defined, wasn't a cage. It was a nice area, probably bigger than this. And they would lower bananas down, and there was like a way to climb up to get the bananas. Orangutans love bananas. So they dropped the bananas down, and poof, they were like a rocket ship going up. But right before they touched the bottom of the ladder system going up, they blasted them with a cold, powerful fire hose. That's why I say they don't do that kind of stuff anymore. We don't want to hurt animals. But blasted them. It took 7 days before the orangutans, they dropped. The orangutans looked up. They looked at where the hose came from, and none of them went and got the bananas, right? That's learned behavior. Now, that's done out of pain. They changed one of the orangutans. They put him in there. He sees the banana. What do you think he's going to do? Bananas! He takes off. Here's the funny thing. They didn't blast him. The other 3 grabbed him, pulled him back. He ran off again. They grabbed him and pulled him back. He ran to get him again. They beat the crap out of him. And every time he got up, they would beat him up. And 3 days later, they dropped. And he looked at them, looked at them, said, I ain't getting those bananas. They replaced every orangutan, and in Italy, every monkey, until none of them had been fire hosed, and they dropped the bananas, and they all looked at each other, and nobody went and got them. That's culture. It's in every organization. It's the hardest thing to change, and if you don't have organizational support, we're just wasting time here. I think I said earlier, 65%, and I don't know who said this, probably Terry O'Hanlon, and he does make stuff up. We all know that. But I think he said at one time, 65% of the maintenance programs that we work don't work. They're ineffective. If you knew that 65% of the energy that you put out produced nothing, you'd stop doing something, right? You'd stop putting out 65% and focus on the 35%. Well, that's where we are in electrical system. And this is the big slide. This is the important one. We all kind of start at the maintenance management department. It could be E&I, maintenance management. Now, electrical systems, we tend to start with the E&I group. Maintenance pushes us down to E&I. So we're working with somebody there, and we want to bring culture change. How likely is it that it's going to change? How likely is it that you're going to go back to your company and you're going to bring about change? It's going to be very unlikely unless you do this. Unless you include the plant operations, then that could be the operations supervisor. Earlier, we looked at the different roles in there. I can promise you it's not the planner and the scheduler. It's going to be somebody that's in that maintenance, operational / production. The person with the P&L responsibility. You got to get them on board. It doesn't have to be corporate. You don't have to go all the way up, but get that person on board. Then you better make sure that purchasing / procurement, here's the difference. Purchasing learns how to say no, because their bonuses typically are on what kind of discount they get. Do I get a discount? 5%. They'll buy crap for a 5% discount. I don't mean to pick on purchasing people, but they're bonused the whole wrong way. They're not looking for the best solution. They're looking for the cheapest. Hey, can you get a discount? Give me a price, then I'll get a discount. I get bonused on the discounts. Procurement, on the other hand, are people that are looking at the design. They're looking at how does it fit into the system. So get the purchasing people out of it and get their bosses, get the procurement people in it. Because procurement people can help make something happen faster than any other group in here. They can also kill it the quickest too. We don't have the budget for that. You don't have approval for that. No, you can't get it. It's not in the budget. Because 9 times out of 10, you're going to hear that. We don't have it in the budget. Well, if we're making dramatic improvement at some point in time, you better put it in a budget. And the procurement people, even if it's next year, I was at a company, that chemical company, big company, and just bought. They had like 32 plants. They just bought 17 more plants. So it's an extremely successful American production company with a couple of other outside the country. But we had every one of their E&I people in there. And their reliability guy, the guy that was trying to bring this to corporate, he wasn't the vice president of corporate reliability, but he had a reliability engineering responsibility by the company. In the company's website, on the website, the president had said, "We will be the most reliable, blah, blah, blah." So I took the quote that he had and I put it on a slide. And I said, I want you to figure out which famous person that you all, and of course they're always thinking historical, who said this? None of them got it. It was their president. I said, so your president said he wants a reliable system, but you're not working as a reliable company. Everybody's doing their own thing. And the reliability guy was trying to bring them together. We had the procurement guy in the room. At the end of this thing, we had done an analysis of just 8 of their 32 plants. And they needed to spend a little over $400,000 on maintenance of transformers alone. 400 grand. And I looked at them and said, how likely is it that you're going to get $400,000 in the budget this year? It's not. It's not. I said, how good would it be if we could give you a 4-year or a 5-year or a 3-year and you'd spend $100,000 and you'd have a plan to fix that which you haven't fixed for the last decade? And he said, I could probably get that through. They did get that through, but it went from 8 plants to 32 plants. You can tell the kind of dollars that they're spending. Procurement can be the biggest blocker or the biggest builder, but you got to get them in early. You got to get them on your side. IT data management. What do most IT people say when you want to hook up any kind of a machine and you want to monitor it, or you want to do it, or you want to do it into their system? Nope, can't do it. Cybersecurity. That's the greatest thing. That's how they stop everything. Nope, that's a cybersecurity problem. We can't. These guys really have a problem. They won't let you hook up anything. They won't let a signal come out of their place to go to somewhere else, even if it's encrypted and it's covered by President Trump. That system can't. They're still not going to let it come out of their plant, are you? And that's happening more and more and more. Why? Because there's cyber hackers. There's pimply-faced guys in their basement trying to do it, and there's some North Koreans trying to do it, and apparently some Russians are trying to do it, and there's just a lot of people, just for the general hell of it, are trying to come in and disrupt all the time. So the IT people have one heck of a job, and it's easier to say no than it is to say yes. But if you get them involved in the beginning and they know what you're trying to do, they tend to not be blockers. Not like the procurement people who can also be your best builders. The IT people won't be your best builders, but they just won't say no. Risk management, this is changing. ISO 55000 is the new risk management ISO. It's happening very slowly in the United States. I think P&G out in California was the first one to actually get ISO certified. They did their gas side. They didn't do their electrical asset side. It cost them millions of dollars to get ISO 55000 certified. They haven't done the electrical side because in the process they found 276 major assets, productive assets that they did not know they had on the books. That's how bad it is, because some of these things we write off, that one writes off, and you don't understand. You got a gas pumping station and you don't even know that it exists. Well, guess what? They found out it exists when they did ISO 55000. They think the electrical side, and you know, they did go bankrupt, but they did think the electrical side was going to be a lot harder to do than the gas side. I'm not sure how fast it's coming, but you know, risk management people are there. Get them on your side. Many of them are impacted by their carrier. Munich Re is the largest reinsurer of electrical systems in the world. And so if you get your carrier and you get your risk management people on side, and part of it, again, is they can say no a lot better than they can say yes. They're also builders, not blockers. Ultimately, finance, they're going to have to say yes. But it gets right down to there's got to be somebody that leads it. It will come out of this discipline. It won't come from the corporate because they say, hey, it's going to happen. It'll come out of the reliability and maintenance discipline. That is the greatest change that we have as an opportunity as professionals in this industry. We can either be the tail being wagged by the dog, or we can take the responsibility. And I don't care whether it's an electrical system or your production system, reliability and maintenance, somebody's going to have to say, I got to put together a lot of different people in order to get this to work. Now, do you put that together? There's a guy, George Prada, I don't know if any of you know him. He is the head of reliability for Constellation Brands. He put together a reliability governance team of all of these kinds of people. He called it a governance team for reliability. Multiple plants, different disciplines, and they got together and get together once a quarter. And they talk about how we're going to do this. So suddenly the culture changed because people are leaving the discipline and say, hey, we got a pretty neat thing going on, this reliability governance team. I'm not too sure about that word because governance tends to be more board oriented. But that's the most important thing to any sort of change to create a more reliable system. We can dally here. We can fix a few things here. We can be led by KPIs by other people where they tell us what the standards are. But if you really want to improve it, which is typically what we find in this industry, one of the things I love about this industry is most of us know what we want to change and know that it's going to be good if we change it. We do. We're not a bunch of people just sucking money or just trying to get over. We're not a bunch of people that leave and retire soon. I could have retired 5 years ago. Some people say I've semi-retired. Mike's coming to it. We're all getting to the point. This is an industry that I think really cares. You know, John, you see a lot of these people in this industry. There's something unique about what we do. But I honestly think it's time, with SMRP growing and Reliability Web growing, and now this conference being here, it is really time for us to kind of have a common voice and say, if you're not going to do that, let us just live by your KPIs and do our normal day-to-day thing, and when it fails, we'll tell you, you could have fixed it, you could have done something differently, but I can promise you it's failing already. You hear about it when it's a major failure of a utility, because then you hear it's in the press. You don't hear about it at a company. Unless I told you about Alcoa, you wouldn't know about that, because nobody wants to give their bad press. They're all going to keep it. We don't learn from each other, but it's happening, folks, day in and day out. Here's why. I don't care what asset you're looking at. You could have motors. Mike, you could come up here with motors. We could be looking at steam traps. We could be looking at anything. This is where we are in the industry. This happens to be the bathtub curve from IEEE for transformers. Pretty neat. Most of it, as you look at that, well, the red light won't work. But as you look at that straight line, that bottom flat out line, that is random failure. Most of the failures are random. Once you get out of the 1 year, that first one, infant mortality, 1 year, random, and even beyond that 20-year mark where somebody named Bill Bartley said, your transformers are going to start failing in 1996. He said that it's 1976. Because the trend was there, right? Bill was the head of the transformer committee. He was Hartford Steam Boiler. He was the guru. He wrote papers, and if you look at the IEEE papers about transformers, Bill Bartley's in there. That's what he said. Well, it didn't happen. They kept running. The average power transformer is 38 years old in industrial America. That's way beyond 20 years. The ones that were maintained, and the best way to maintain a transformer is just keep the oil clean and dry. The maintained ones can last a lot longer. We have a course called the half century. What we mean is you can get 50 years life out of a train. There are no moving parts. There are a lot of moving protons and electrons, but there are no moving parts if you don't have a load tap changer. So Bill said that's true. And guess what? Everybody paid attention to that. We need to keep these old assets going. We need to make sure let's monitor them. Let's make sure they're going here. And all along, something's changing. Omicron came in 6 years ago at IEEE and said, oh, we have data that says the infant mortality rate is 3 years. Well, that's different. You got a lot more risk now for 3 years, right? Nobody knows why. All of a sudden, the insurance industry, FM Global and others said, no, it's not 50, it's not 3 years, it's 10 years. The infant mortality on new transformers is 10 years. So should we be paying as much attention to the 10 years as we do to those? People aren't, it's new, I replaced it. I think it's Arizona Public Power or one of the Arizona things. They rewind their old generation transformers rather than replace them, because when they replace them, they don't work as well. So they rewind them and they return them to the same robust state. I have a case up there, it's Gerdau. I'm going to give you a different one. This is for you. Luminant Technologies was replacing a 950 MVA transformer, pretty big transformer, right, in Houston. They used to run that transformer at 20% over rating, so they're running that transformer at over 1,000 MVA. So they're replacing it. Siemens, who I happen to think is a really good manufacturer, ABB and Siemens are like there, right? I used to say they're the Siemens and ABB, really good manufacturers. And Siemens in and Siemens out. We were just getting back into that business and they knew some of our people, so we were managing it. We didn't have the crews to do the work, so we were going to be the contractor managing it. And we had to get cranes, right? The crane for the new one was 5 tons lighter than the crane for the old one. 950 MVA, bigger than an 840 it was replacing, and it was 5 tons. What did they take out? They took out paper or oil. They took out anything that we overbuilt the transformer with. You know why? Georgia Tech, I used a 5-line slide rule. Some of you don't even know what that is, right? And you did everything by here. And I had a professor say one time, I started in aerospace engineering, and he said, Ross, if you screw up, planes fall out of the sky. Well, guess what? I didn't screw up. I switched to mechanical. It was just easier to do. But the point being, we overbuilt everything. We overbuilt motors, we overbuilt cables, we overbuilt everything electronic. And now we build them to what? Rating, spec, because no company can afford to give you an overbuilt product. Why? Is it because the purchasing and procurement won't pay for it. So that's why all of the rewind facilities are booming right now, whether it's Solomon or Jordan or OTC Transformer. They're all full because people are rewinding and rebuilding transformers to the old spec, the old robustness. New ones are giving us problems in every asset class. And the system itself is changing. When you put relays into a system, you may find that you got different problems, especially power quality problems. And so consequently, the bathtub curve for all of these assets has changed. We haven't even kept up with it. It took the Transformer Committee of IEEE 6 years to come up with a new gas guide. 6 years. My gosh. And they came up with Duvall's Triangle. He had that, what, 10 years, 20 years ago? I mean, it's ridiculous how long it took to say, here's our new standard. They're still antiquated. And now he's got a pentagram or pentagon, what do you call it? The Pentagon. Just very simply, every asset needs some form of reliability-centered maintenance program for it. That's what our job should be. Hey, and you heard it this morning, decide which ones are critical. Put up a criticality analysis, know which assets are critical. The same is true for all of your assets. Here's the deal though. The system is what we ought to look like. Because you can say, hey, that asset is more critical than that asset. But as it turns out, this system is more critical than that system. That's one of the things that's changing. I did a webinar, Smart Grid Reliability Alliance for IEEE. You don't get to do an IEEE webinar without a whole bunch of people shooting at you, right? They're going to pick at everything that you write on that thing. They're going to make sure you do it right. Well, as I did it, it did pretty well, and a lot of people asked questions, and it got in there. But somebody, Pat Ryan, the executive director, said at a conference, he said, so we ought to look at maybe making, I know we got smart grid, I know we got grid edge, we got this, we got smart village. He said, we ought to look at some way to be able to incorporate this as a working group. I'd be like a transformer group, right? That means I'd get buried in hell before I could do anything good. And I said, you know, Pat, here's the problem. I come from the Reliability Society. I think that's what Jordan said. I'm a member of the Reliability Society of IEEE. You know what they work on? Component reliability. They get down here and they look at parts and component parts. They don't look at system reliability. And you got all these working groups, the transformer group and this group and that group, but they don't look at cross-functional reliability. So we're actually putting a memorandum of understanding where we get to bring that group and touch and absolutely be part of all of these other different groups. And I say we, the alliance is kind of blown up a little bit, and it's actually our way of saying, look at your system reliability, don't look at your asset reliability. My fear is that ISO 55000 is going to get us all again to look at the asset, not to look at the system that that asset is part of. For those of us in this room that are under 50 years old, mark my words, if you focus on system reliability, you'll be the people leading it. Because most people are looking at asset reliability, and the guys that work at asset reliability will be calling you boss. So ultimately, it's like anything. You want to standardize programs? Standardize the testing, chemical, mechanical, electrical, regardless of what the asset is. Are there ways to do electrical testing of cables? Absolutely. There's a company called MCorp. I don't know if ABB's got that, but they do some amazing things. It was in the IEEE webinar. I did a case with MCorp's help. It was, I think, Constellation Energy in Houston, who ended up buying Luminant. But Constellation had a huge problem with underground cable. They saved them 85%, which was millions of dollars of replacing, not replacing cable they were going to replace because of age. They replaced only the areas that needed replacement. Southern Cal Edison did a great job of determining how to change all of their their distribution transformers, their replacement. Rather than do one thing, age, they decided to do age, condition, a number of other things. They saved millions of dollars a year because they're not just replacing old equipment. They're looking at it and saying, let's replace the equipment before it fails, not just because it's old. And let's keep good equipment longer. So it helps everything. When the asset life extends, you get less cost for replacing it all. And you get increased reliability because new doesn't necessarily work. Standardize your data management. Everybody's selling us data management. If you don't have a data management system, and it's usually for electrical systems, it's not in the SAPs, it's not in SIM, it's not in any of these people. Other than, I saw in SIM where you had electrical in there. He's not here in the room, but you had electrical in there. I have not seen that before, where you actually have in the maintenance tracking and planning, where you have your electrical part of it. That's excellent. I mean, typically, that's why I asked you to show that to me again, where you can see the red area and you got the mechanical area and the electrical area. That's the beginning of being able to look at what your people are working on. It's not typical in our high voltage system. Standardize the maintenance. If it says this, do that. In electrical systems, they give you warnings. They tell you a partial discharge. I know Omicron's got a new system that is just brilliant. And that system goes right into a database and begins to give you some predictive maintenance on all of those assets we talked about right there. And I'm sure everybody else is coming up with the same thing that takes ultrasound and IR, combines them to look for partial discharge, which is a great way to determine if you got a problem. We do chemical testing. Slow, it's annual, it's expensive compared to there's a lot of new things coming online for electrical systems that are changing it all. Standardized monitoring, everybody's building monitors. I know, Qualitrol is talking about 27 different monitors for a power transformer. That's great. Where does all the data go? I know First Energy has 600 monitors on their transformer shut down because they don't, too much data. If they responded to all of the monitor data, they'd shut down everything. So now they're trying to figure out, how do we do data management? And then you train people. You get the right training, education, and development for the right tool. The right person with the right tool in the right place at the right time. That's really what reliability is all about when you tie it to maintenance. That's an actual report that I went to a client. He loved those. He had binders of those. That's how we used to send it out at SD Myers. Then we revolutionized the industry, went to something called the Rainbow Report. We put color. It's called a Rainbow Report. So that guy had every report for over 30 years that we did. So I go out to him. He was 78 years old in the Upper Peninsula of Michigan. And he's got them in these big green binders. He keeps adding them every test thing we do. Sitting across from him is a guy that's got, and I said, so are you going to follow up on this? And the guy across from pulled out a BlackBerry. It was before iPhones. He shows a BlackBerry. It's a different world. This generation wants it, and they want it mobile. They want it now. They want alerts. They want to be alarmed. They don't want it to read that. They want to know this. What's red? Fix it. You saw that on the thing. If it's red, it's bad. Fix it. You know what I love about C-level people? Is if they come into a room and you got a screen up and there's anything, what's wrong with the red? And they'll tell you to fix it. And you can say, I've been asking for $100 to fix that for 10 years. But he'll look at it and go, fix the red, get it out of there. These guys hate red. Nuclear red is bad because that means we should all run. But the point is, it's a lot easier for anybody. This goes back to the ISO 55000 rule. Make it easier for people to know what's going on. You can pretty much look at that and say, that report all over there, I can kind of see within 10 minutes, even though I don't know what I'm looking at, I can kind of see a dashboard. Everybody's got them. They all give us ways to manage through them, right? So when you do that, the best way to do it is who owns the asset, and not owns it like the corporate ownership. You know who owns an asset? The production people own the asset. If that thing isn't working, they're not working. No wonder production people hate maintenance people many times, because we try to take their most important productive assets out of service to work on them. And it's a catch-22. If we don't do that, it'll take itself out of service. That's the neat thing about assets. If you don't take care of them, they'll handle it. They'll just stop working. And they always do it on a Saturday morning or a Friday night at 11 o'clock, right? At the Christmas break. That's when they always break, so you got to scramble and figure out how to get somebody in to do something with it if you're a 24/7. You got to do it as a team. You cannot do this. You may not get everybody I talked about in there, but you will never do it alone, coming from the maintenance discipline or the reliability discipline. You've got to bring in other people. And if I could only bring in one, you know who I'd bring in? Whoever has P&L responsibility for that facility. The second person I'd bring in would be the procurement people. That's the closest thing that you can get to the P&L. You say, hey, we got to change the way we're doing this. And guess what? There is a lot of good information, including information that IEEE puts out, we put out. Companies give a lot of information on the risk of not taking care of electrical system assets. I love this one. Tutoade, that's an African word. That's the way we have always done it. Somebody mentioned that earlier. Tutoade, right? That's the way we've always done it. The first barrier is, but that's the way we've always done it. Screw that. What if it's wrong? What if it's not going to work anymore? What if the assets are old? What if the new ones aren't made the same way? You better do it differently. Sometimes people say, well, I got 17 people working for me. Jobs is power. That's one of the things in company. How many people you got working for you? Poor Sean here's got 30 people. Jesus had 12 and one was a devil. I don't know how you think you can manage 30 people. So the idea that, I don't want to lose any people that work for me, because if I do, guess what's going to happen? I don't get as much authority and power. I don't get a raise. Fear of loss of control from plant to corporate. Plant managers hate corporate. We hate government telling us what to do. Plant managers hate corporate telling them what to do. So there's that sense of, is it a corporate program, another damn corporate program, and we got to implement the program. It's the flavor of the month. Oh man, have I been through that. I have been part of the flavor of the month more than I can remember. I used to do a lot of talks at an organization that were more on the motivational side. And I would always then, hey, would you come in and talk to our people? It was always the flavor of the month. They liked it for a while, but it's like, yeah, but Tatuade, as soon as you leave, that's the way we've always done it. That's the way we're going to do it. Because the CEO just liked what you said, the book of the month. I have a dear friend of mine, CEO, I told him to stop reading. Every time you read a new book, you send the book out to all of your management team. Most of them don't read, not that they can't, but you keep sending these books out every month and you want them to read it. It's the flavor of the month. It's Covey, and then it's the next guy, and the next guy, and then some spiritual guy, then this guy, and Rabbi Feinberg. You get all these books that come in there, and suddenly you got your people confused. Unclear expectations. What are we trying to do? And let's get it done today. Let's get it moving. You will not change the reliability culture, whether it's electrical system or the entire, you won't change it in anything under 7 years. I believe that. I mean, and there are statistics that talk about culture change. Do you have a 7-year commitment to something? Most of us in this room don't want to be in the same job 7 years from now. We'd like the promotion. We'd like something else. We might be in a new company. And the next generation moves around so doggone much, they'll never be in the same place 7 years. And so consequently, it doesn't happen because it's going to take a lot of time to bring it. And then this change between people. I don't understand millennials at all. I do understand Gen Xers because I have some. I am a boomer. You know, I'm a baby boomer from after the Second World War, and we're tired. We're tired of the fact that we've run this thing, and then the next generation says, "Yeah, but you've screwed it up." Here's the other thing. We also have more legacy knowledge than you can possibly imagine, and a lot of it's not being captured. And some of it's not being captured because we're so damn selfish. We keep it to ourselves. We ought to be sharing this knowledge, and we ought to be passing it on to the next generation. We ought to be making the guys that are going to be handling this thing long term, whether it's 5 years, 10 years, 20 years, we ought to be pouring ourselves into them at conferences like this and other conferences. And doing it not just because we're going to make a penny off of them, but doing it because it's the right thing to do. I'm not going to go much into this. We had this is a refinery in Northeast Ohio. They had some transformers that had a really bad moisture problems in them, and they didn't do anything about it. They left them there, and then they began to have not catastrophic failures, but failures. Most of the industry now buys the fact that gas is a problem. Moisture is the beginning of the problem. So you got to keep the moisture out of a transformer. Long and short of it is, we defined it. We said, here's the solution. Procurement said no. And then they started having problems. So we went back in, and instead of selling them $400,000 worth of equipment, we just sold them a solution over time. In 10 years, we can dry out your transformers. It took about 5. All their transformers are dry. They don't have any problems anymore. There are ways to do it. The outcome was we got what was close to a $500,000 approval from procurement by doing it $800,000, $80,000 at a time. We had to change the way as a customer, as a vendor, we had to change the way we did what we did. And we had pushed for 3 years to solve the problem our way. And finally, when they came to me and said, here's what they think they can do, we went from selling them a piece of equipment to renting them a piece of equipment with a purchase after the end of it, which worked out. We made more money in the long term. We solved their problem, but we had to listen. Do what?
They got 100% write-off for that too.
They did, yeah. So, and that's sometimes why it doesn't happen the way it's happened. So it was perfect for everybody, but that's why we as vendors, as the 1099 people, need to listen to the problem and come up with an efficient solution that the guys we're talking to can get approved. If they can't get it approved, it's not a good solution. An approvable solution is what we need. We had another one. I'm not going to... Oh, this one I'd really love. That's a steel line, right? Steel plant in Northeast Ohio. And that steel line, they had 3 different basic areas of the plant. So you had the raw production, which would then go into another kind of a mini mill, and then you had the shaping or whatever they call that, but 3 basic areas of the plant. And there was one transformer, furnace transformer, at their main line that was the problem. We had diagnosed it, everybody saw it, it was great, we gave them the solution, nothing happened. They didn't return phone calls, they didn't do anything. The sales engineer that was working on this said, you know, Lost, no reason. It just never called back. Emails, whatever it was, lost, no reason, until 14 months later. Hey, we just had a transformer fail. We got to do it. It was that transformer. So when we went in to look at it, that shutdown affected every other area of the plant. The whole thing shut down as a result of that one transformer. We implemented some new programs. The cost of savings for 1099 people, somebody mentioned how many contractors they had in there. They had 10 1099 contractors, not one contractor, but different people working different. So from a systemized approach, not our approach, from their approach, systemized, they were able to save enough money to replace that transformer. Now the loss was the loss, but they have an efficient system. It's now working, and where they had whatever 10 1099, they have 3 who do the whole plant. And it's kind of a bidding thing because everybody wanted in on that. But this plant manager didn't respect this plant manager, didn't, in the same facility. Happens all the time. It's called suboptimization, and it happens in the electrical system. Oh, that's the E&I guys. Oh, that's the electrical guys. That's them. That's not us. If the transformer, the cable, the relay doesn't relay, the breaker doesn't break, and it goes down, guess what? The whole plant goes down. I love all this. See how fast I could click through here. And lastly, and they say in conclusion. So what do you do next? I'm going to go along with what our friend said earlier this morning. Know the criticality of the assets. Make sure that you've got a criticality ranking of your electrical system. Not of your transformers and of a system. This one line supports that system. We are doing it for Cleveland Clinic right now. They didn't realize that they had problems because they put in all these machines they put in suck more power. They don't have double-ended subs anymore. They don't have the redundancy that they thought they had anymore. And we all realize now that the generators don't last as long as they are supposed to, and you don't want to run off of a generator because power quality goes through the roof bad. We had a freezer company install brand new freezers, very good state-of-the-art freezers, all of them hooked into a system so they could look at the temperature in each one. If you opened up freezers and put in food, it was a food processing facility, you could see the temperature drop. The pumps would pump up. They would get more air in there. They'd close the door and then everything was, but you talk about fully automated system. They installed it. We're talking millions of dollars, and the freezers began to fail. Boom, boom, boom. They bring in the freezer company. We got a problem. Your freezers are failing. This is not working. The freezer company can't figure out why they're failing. And here's an electrician, company electrician, going through, and he finds there was always a harmonic load on one line that goes to the freezers. Small harmonic load that never was a problem in the past, but the new freezers are all microprocessor controlled, and this little bad boy buzzed them off from time to time whenever you get a harmonic load in the line. And for $1,500, they solved the problem, whereas they were going to make them take out all the freezers. That's a power quality issue. That's where relays come in and do stuff. Data centers are hugely impacted by power quality issues. So you better know what the system is and look at the whole one line as it feeds it. What's the risk? What's the current condition? I'm amazed at people that replace assets because they're old, not because they're bad. You may have more risk, as we said, from newer ones than you have from older ones. There's less than for a 4 MVA transformer today. There is half of the oil, half of the weight, half of the paper, and about 70% of the copper than there was in a 4 MVA in 1965. They were overbuilt. They were great beasts. And if they're still working, keep them alive. Just keep the oil clean. You know, make sure that the connections aren't loose. Change your bushing every now and then. Make sure the gauges work. Develop your long-term strategy, your standards. We do it because the CMMS does it for other systems. It doesn't necessarily do it for electrical equipment. It will soon, because as I understand it, Maximo's working on that, SAP's working on that. People are working on how to get electrical system standards, and there's just not enough of the assets, and they're so unique. You know, every transformer, like every one of them was made unique. And that's, I don't know if it was the buyers or the sellers. Create a multi-year budget, and then start doing the real life cycle management, which I think people like Life Cycle Institute, yeah, LCI down in, yeah, they do a lot of work on life cycle management. But that's it, criticality, risk, standardize it, maintain, and then figure out life cycle on it. That's it. My official duties as host and co-host are over right now, Jordan. Any questions about the presentation? Does no questions mean they don't care, or what does that mean?
You get them as you go.
No, I'm not a get them as a go guy. Yeah, there's a lot to share here. Questions, comments? Everybody got a very robust electrical system program? Yes, sir. Yeah.
I have a question about these assets from which you can generate a work order. Okay, that asset, is it on any, is it computerized? Is it on any programmable controller? You know, because anything you can put in a BSD file, maximum NSAP actually can read it and generate whatever you want out of it.
The point is, you get a condition, you get a work order, right? We have not put those standards in that system. So the asset may be reportable, but a work order is not. So what's happened is we in the industry have all created our own work order systems. We've done workarounds on the work order system. We happen to call them service alerts. It says you need to do this service on the asset. I don't know of any in the cable industry. I don't know of any that take in assets of cables, relays, breakers. I mean, you work in that industry.
What I'm telling you is, I know it's a fact for Maximo, and I'm pretty sure it does in SAP. Whatever your controller, automatic, you know, what your controller of that can do, if it can write it down in a BSD file somewhere, I can read it and pop out an alert, a work order on anything.
I realize that.
I just have a short comment, which is, I hate to even hear the word software in the conversation, whether it's Maximo, SAP, PM, or Oracle, or whatever. It comes down to vision, and if the product can be configured, whether it's a data stream or MP2 or whatever, you're golden. So it requires a visionary, it requires a plan for excellence, operational excellence, and if the product can be configured, you're good. That's all it is.
There's a standardization of configuration. There's just every electrical, let's deal with transformers, Dinesh. You guys probably know this. They're all so unique. It's not like it's not like a motor that the manufacturer of the motor gives you the things that you need to configure in Maximo because that's what they want. That's not true. Plus they're older assets. So this was there before some of these other systems were there to tell you what to do. And I don't know that any of the newer, I don't know, and here so you've got Asset Century, right? Century. That's supposed to look at that, but that's separate from a Maximo or separate from an SAP.
Well, we have,
Grab a mic.
So what we have is a, industrial automation product which is called Pro Service. And basically it's a CMMS system, but modified to the assets and looking at the system together. So what we have done is, automatically health and time-based work order creation. Now you can be very critical about, what assets and where you want the thresholds. And in the morning you could have 5,000 work orders, which are useless. Right? You can go to that extent that, or you want to do maintenance on all these things and, it's pushing it out, but you have to look at the balancing, what we talked about earlier. But the work orders can be created in a smart way, which means, again, going back to the way ABB has done all the pro service work is, look at what tools you need, what are the requirements, the critical, your flow chart with the critical path, for what the production, what the goal should be, the level of the expert that you need, the shutdown time required, you have to match all of those, and then you generate the work orders. And if you think this is not, if you want to decide we don't need to do this maintenance on the transformer. We don't want to do it DGA at this time. You just check mark it, skipped it, so that it gets bounced over to the next time. Or what you do is you can have it in the queue, and if you don't have all the parts, let's say you have 100 and not 100%, 120% work scheduled, and something gets slipped, then you can accommodate other things that could be done. But having more knowledge of what type of maintenance, what are the requirements, helps, and that's done through the work orders.
Okay.
So we have that system.
All right, we're going to switch gears. It's time for a coffee break, right? And then we're going to come back here, and Mike, you're up next. Are you up next? Can I mic you up? And we do that. Thank you all very much.